Hi, my name is Alan Baker. This video is the last part on transmitting humidity and temperature data from a sensor in a ZigBee network at AT mode. Today I'll be talking about transmitting the data through a miniaturized system. In part 1 I described the Arduino Uno development board and an equivalent development board. I then showed you how to check that the device software is functioning correctly. I then described the DHT11 and DHT22 humidity and temperature sensors. Finally, I was able to link up the sensors with a development board and through a sketch was able to show you a data output on a laptop screen. In part 2 I showed you how to set up the XBees at AT mode. Then I demonstrated a video example of the XBees in operation, transmitting and receiving sensor data in a ZigBee network. In part 3 I'll start by showing you a short video of the miniaturized system in operation. I'll then show you how to program an Arduino Nano or an Arduino Nano clone. I'll then show you how to build a portable miniaturized system. I'll then end with a longer video example of the miniaturized system in action with a laptop. Okay, let's start with a short video example of the miniaturized system. To the left of the breadboard is a simple on-off switch. This is attached to the ground terminal. This is followed by a voltage regulator circuit which includes two electrolytic capacitors. You can buy these circuits already built, and I'll show you 3 examples later on. The voltage regulator circuit reduces the voltage down from 9 volts to 5 volts. One thing to remember about electrolytic capacitors is that the cathode side must be placed in the ground rail. The cathode side is identified by a grey band running top to bottom. In some products, this band is black instead of grey. If in error you put the cathode connector in the positive rail, the 5-volt regulator will overheat and can be destroyed. It will also burn your fingers on contact, so turn off the power first and let it cool down. Next to the voltage regulator circuit is the XBee, which is followed by the DHT22 humidity and temperature sensor. And finally, next to the sensor is an Arduino Nano, in this case a clone version. I did put an order in for the original product. However, in this coronavirus lockdown, it has not been delivered at the time that I'm making this video. Now you should not face any problems with the original Arduino Nano product. The clone version, on the other hand, is a different matter. There might be several issues to fix first. If you search the web, there are many articles on how to fix these issues. On my clone, I had problems with the software driver and the bootloader. The bootloader enables loading the compiled sketch. To fix my problems, I needed to download a different software driver, the CH340, and secondly, I needed to use the old bootloader as opposed to the new one. The old bootloader has a bug related to a watchdog reset. Fortunately, I'm not going to use this feature. I went to the following approved site to download the software driver. I then set it up in my system. That looks more stable now. But to be sure, I checked it with the device manager. The sketch is loaded into the Arduino Nano clone in a similar way to what I did with the Arduino Uno. It is first compiled and then loaded into the Arduino Nano clone. If I was not using an Arduino Nano clone, I would select the ATmega328P, the new bootloader for the processor. I would also check and select the COM port again. This is because the system may be using another COM port and the sketch consequently will not be downloaded. When using the cloned version, it took several attempts to be successful at downloading a compiled sketch. After that, I had no further problems in downloading a compiled sketch into two of my Arduino Nano clones. The current price for Arduino Nanos are £15 or $13 for 3 cloned versions, or £20 or $19 for an original product. This is a list of parts that I used for the miniaturized system. Because some of these parts are scarce at the moment due to the lockdown in the country, this is reflected in their price. So I suggest you just sit back, enjoy the rest of the video and wait for better economic times to prevail. Next, I'll cover the electronic components in the system. I'll start with a circuit diagram and then I'll show you 7 photographs, 6 of which are labelled. The circuit diagram and the 7 photographs last about 15 seconds each. This will give you plenty of opportunity to stop the video and have a closer look. One final reminder that if you attempt the circuit yourself, you must connect the cathode side of the electrolytic capacitor to the negative rail. The cathode side will have a grey or a black band running from top to bottom. This is to prevent any damage to the circuit or yourself should you touch the 5V regulator from incorrectly wiring up the capacitor. I mentioned earlier that if you did not want to build your own regulator circuit, then there were already built ones on the market. Here are 3 such examples. The first product from the left comes as a pack of 5 for £6 or $6. The second product from the left comes as a pack of 5 for £10 or $10. In both these products, the output voltage has to be adjusted to 5 volts by means of a brass screw in the blue box component. The last product, the iHeo Space, comes at a price of £6 or $6 for 2. This one I found the most useful, as it would take an input between 7.5 volts and 20 volts and reduce it to 5 volts without any adjustment to a brass screw. That's all that remains now, is to test the system in the garden. Bye for now.